Okay, so I'm going to attempt to lecture on section 4.4 this morning. Hopefully this comes out okay. This is kind of a disturbing day for me to be here. It's Sunday morning during summer vacation, which is, and 5:30 in the morning at that. So this is really a bizarre time to be here, but it's when I'm functioning. So hopefully this comes out okay. But if it doesn't, then I'll redo it. Most of the problems in section 4.4 are word problems. The beginning problems all start off and they give us a formula. And if you understand the formula, then answering the questions will be easier than if you don't understand the formula. So for the first few problems, I'll take a second and try to just explain the formulas. So the formula in this problem, number 2, which is the first even problem, in the write-up, it says that this formula is related to some object that's fired vertically into the air with an initial velocity of 96 feet per second, which is at 96 feet, not 96 for that matter, but that you don't really need so much because the equation's given to you. What's important is how the problem describes the letters. And it very specifically says what this function is going to give me. It's going to give me the height of the object in feet, t seconds after launching. So for instance, if I plug in 1 for t, this is just to help you understand the function. If I plug in 1 for t, t stands for the time in seconds. So if I plug in 1 for t and go 96 times 1 minus 16 times 1 squared and get 80, this would say at 1 second the object is 80 feet high. So there's 2 letters in the formula. The H represents the height in feet, and the T represents time, and then it says in seconds. So I should completely understand how the function works. If I was to sketch a graph of this, the x coordinates of any point is going to be a time. The y coordinate is going to be the height in feet. And let me go ahead and just sketch a graph just so you can see that this point on a graph. So let me go y equals clear. I'm going to go 96x minus 16x squared. I can't make the y's turn into h's, nor will I want to make the x's into t's. When I go to graph this, first of all, I need to think about a reasonable window. The x's have to do with when this object is traveling in the air, and honestly, it wouldn't make sense to have a time less than 0. So when I go to set my window on this, my x min is going to be 0 because negative x's, or negative t's in this case, would be before I launched, or before the object was launched vertically into the air. And although you can plug those numbers into the function, plugging -3 in for t would give me a value. It would say how high the object was 3 seconds before I fired it. And although I can do the math, that math wouldn't make sense relative to this problem. Similarly, I'm not going to make my x max too terribly large. I assume that when you shoot something into the air, that it's not going to stay in the air for 50 seconds. It's going to go up and down pretty quickly. I'm going to make my x max maybe 20, which will show 20 seconds of flight. Again, I can put a number like 300 in for t, which would compute the height after 300 seconds, which is 5 minutes. But again, even though I can plug the numbers in, it might not really make sense. There are only certain numbers that make sense to plug in for t, and that's the times when the object is actually before I fire the before the object is fired into the air, that represents negative time, and after the object hits the ground, I can get values. I can plug values in for t and get numbers, but those numbers won't make sense. And then similarly, for my y min and y max, when I go to do this window, I'm going to do 0 for my y min. The y stands for the height in this case, and my object isn't going to go underground, and maybe if it hits the ground it might bury itself a few inches, but I'm going to put 0 for my y min. And then my y max is the maximum height. I'm not sure what the maximum height is, but at 1 second it was 80 feet high. I'm going to gamble on a maximum height. I have no idea what the maximum height is, but it looks like maybe 300 feet might be reasonable. So I'm going to sketch a graph just to show you what the function looks like. I'm changing my window to go from 0 to 20. That's showing 20 seconds of flight. And from a height of 0 feet to a height of 300 feet. And again, I made these numbers up because they just seem to fit with the problem. Now when I hit graph, hopefully I see a parabola that opens downwards, and I can actually see the vertex just fine. So this shows the flight of the object. The point that I found, the point 180, let me show it to you. I'll show you that point by hitting my second, calc, hitting enter on value, typing enter at 1. So this shows at 1 second the object was 80 feet into the air. If I plug 2 into the function, if I did second, calc, value, and typed in 2, it would show me at 2 seconds it was 128 feet in the air. If I do 3, second, calc, value, type in 3, at 3 seconds it's at 144 feet in the air. To me that looks like that's as high as it gets. It looks like the vertex of the parabola. If I type in 4, did second, calc, value, 4, it says at 4 seconds it's back to 128 feet in the air and it's starting to go down. So it looks like for the first 3 seconds it's going up, and then it starts going down, and eventually it hits the ground again. And once it hits the ground, I'm not going to look at the function outside this little parameter. So even though I can plug numbers, any number in for t, there's only certain numbers that will actually make sense relative to this problem. So this is the picture of what's going on. So just real quickly, it looked to me like the graph looks something like this, and I found the point 180 by hand, which means at 1 second it was at 80 feet. This point, this 3,144, that looked to be the vertex. That looked to be at 3 seconds it was at 144 feet, and that's the highest the object would go. So this had really nothing to do per se with solving the problem, but everything hopefully for understanding the problem. So now I'm going to solve all the questions. It may turn out that just doing this little sketching and discussing the problem that I might have inadvertently answered some of my questions, which would be nice. If I know the answers for the questions before I do them, then the algebra that I do to get the answers will just kind of confirm what I already know. So let me get into the problems themselves. And first thing I'm working at is problem part A. And it says very specifically, at which times will the object have a height of 80 feet? Well, I know that at 1 second the object had a height of 80 feet because I just did that. But that's on the way up. It also, on the way down, hits 80 feet again. So there's going to be 2 times where the object has a height of 80 feet. One of them is going to be 1 second. To get that solved for, I need to take the 80 and work it into the formula. Because the 80 stands for the height of the object, the algebraic strategy I'm going to do is I'm going to plug in 80 for the height, and I'm going to solve for the times. And I'm going to get 2 times that this happens. Because there's a square, I want to set this equal to 0. Forgot the t here. And I like having the square term positive. So to get this set to 0, I'm going to minus 96t and add 16t squared to both sides. When I do that, on the left-hand side, I get 16t squared minus 96t, 96t plus 80, and on the right side I zeroed everything out. So solving this problem, putting 80 in for the height, will give me the times that the object is 80 feet in the air. This is a mess to solve. When you have a problem that has an equal sign and a common number factor, you can divide it out. I'm going to divide each of these by 16. I also have to divide the 0 by 16. When I do that, the 16's in front of the t squareds cancel. I'm left with just a plain t squared. The minus sign in front of the 96t stays there. But when I divide 96 divided by 16, I get 6. And 80 divided by 16 is 5. And to the right of the equal sign, 0 divided by 16 is 0. So when a problem has an equal sign, like as this problem does, and there's a number common factor without a letter, you can just divide it away. Makes the numbers a lot smaller, doesn't change the solution. Now I can solve this. This is not hard to factor, so I'm going to factor it. I know that my first have to be t and t to multiply out to be t squared. My last have to multiply to 5 and add to 6. And that's going to be a minus, add to negative 6 actually, a minus 5 and a minus 1. So that t squared minus 6t minus 5 factors into t minus 5 times t minus 1. Now that I have it both set equal to 0 and factored, I'll separate each factor, each one separately equal to 0. For the t minus 5, you'll add 5 to both sides and get t equal to 5. For the t minus 1, you'll add 1 to both sides and get t equal to 1. The answer to part A, the times that this object is 80 feet in the air, are at 1 second and then again at 5 seconds. So at 1 and 5 seconds, the object's 80 feet into the air. And I can show you that quickly on my graph. If I did second calc value and typed enter on 1, you'd see that at second calc value enter on 1, you'd see at 1 second it's at 80 feet in the air by looking at that point 180. Similarly, if I do second calc value and type in 5, it also shows me at 5 seconds it's also at 80. So it goes up past 80 feet, goes higher, then back down to 80 feet. So at 1 and 5 seconds it's at 80 feet. The next question is, how long will it take to hit the ground? It hits the ground right there. The x-coordinate of that point is when the graph hits the ground. And if I count the little tick marks here, it looks like 1, 2, 3, 4, 5. It looks like 6. It looks like it takes 6 seconds to hit the ground. I'm going to do the algebra to confirm that. But just based on my picture, knowing that that spot right there is when the object hits the ground, is when the x-axis is serving as the ground here. It looks like the answer is 6 seconds. The algebraic way to get that, hitting the ground means the height is 0 because the ground is at a height of 0 feet. So I'm really, part B is asking me when is the object at 0 feet in the air. And algebraically I'll do that by setting the equation equal to 0. And just like the last problem, I don't like those big numbers. I can divide the big numbers out a little bit by dividing everything by 16. So when a problem has an equal sign and a common factor, you can divide away that numerical common factor. And when I do this, I get 0 equals 6t minus t squared. When I'm solving this, I'm going to solve by factoring. There's a t on either side of the minus sign, so I'm going to factor out a t and get 0 equal to t times 6 minus t. I have the problem set equal to 0 and factored. So now I'm going to take each of the factors and set them equal to 0. The first factor says at 0 seconds, the object is at 0 feet. That means it starts out at 0 feet. It started off on the ground and not slightly above the ground. The second factor of 6 minus t is going to give me the answer I'm looking for. If I add t to both sides, I get 6 equal to t. 6 equal to t. T stands for the time in seconds. 6 stands for 6 seconds. So the object is going to take 6 seconds to hit the ground, and I kind of figured that out by just counting the little tick marks. So the answer to this is going to be at 6 seconds. I'm going to do something a little bit different when I do the algebra for part C that you may have seen in intermediate algebra that you need to see again. The answer to part C, what is the maximum height? As I was plotting these points in, when I plugged in 3, it looked to me like at 3 seconds the object was 144 feet in the air, and that was the highest, the maximum height. So the maximum height is the y-coordinate of the vertex. So part C is really asking me to find the y-coordinate of the vertex. I can certainly use my calculator to find the y-coordinate of the vertex, but I need to be able to do it with algebra when it comes to the test. So I'm going to do the algebra to find the whole vertex. I'm actually going to find that at 3 seconds, the object is 144 feet in the air. My answer is just going to be the 144 feet. I'm going to get that by retaking the function, rewriting it with the squared term first, in the last section, we figured out a way to use completing the square to write the problem so I could pick off the vertex. I'm not going to use that strategy. I'm going to use the formula strategy to find the vertex. So the first thing I'm going to do is I'm going to find the 3 seconds. I'm going to find the x-coordinate of the vertex by hand. And hopefully in intermediate algebra you learned the formula negative b over 2a. If you have a parabola and you know the a and the b, you can find the x-coordinate of the vertex by just using that little formula. And very specifically, the a is the number in front of the squared term, which is negative 16. The b is the number in front of the first power term, which is 96. So for this formula, I'm going to go negative and then b, which is 96, over 2, and then times a, which is negative 16. This is going to give me negative 96 over negative 32, which is 3. That's the 3, that's the x-coordinate of the vertex. That's saying the object reaches its maximum height at 3 seconds. I don't need a special formula to get the y-coordinate of the vertex. To get the y-coordinate of the vertex by hand, I can just plug the 3 that is the x-coordinate of the vertex in for both of the t's in the function. So if I go negative 16 times 3 squared plus 96 times 3, I'm going to get the 144. So let me do this. I'm going to go negative 16 times 3 squared plus 96 times 3. That's just plugging in the numbers, the number 3 in for t, and I get the 144. So the vertex is the point 344 because every point on this graph, the x-coordinate represents the time in seconds, the y-coordinate represents the height in feet. I'm going to answer the maximum height is 144 feet. You need to be able to find the answer to all of the questions via algebra. You can use your calculator to confirm your answers, but on the test you need to do some algebra because this is an algebra class and you need to build your algebra skills and get them, performing at their highest levels so that if you have to take calculus, that your algebra skills aren't going to be the thing that wears you down, because calculus without algebra is not hard. It's the algebra in calculus that's hard. So forcing you to do the algebra here is hopefully going to make calculus, if you have to take it, better than if you don't push your algebra skills. So I'm going to do something similar for 4. I'm going to try to talk about the equation, maybe figure out the answer to the equation by just playing around with my calculator, and then I'll do it by hand. So number 4 has a student tossing a water balloon off the roof of an apartment, and The function tells me how high the water balloon is for a given time. So apparently the apartment building must be 112 feet high. This 112 that doesn't have a letter in these styles of problems, that's usually the initial height. In our last equation, there wasn't a number after the t pieces, because if you kind of look at the pieces, there's that same negative 16t squared, and then I had a 96t and there's a 48t, so those pieces are kind of similar. The first function didn't have this plus extra number. That extra number, that constant, usually is the initial height. And in part question 2, the object started at ground level. At problem 4, because I'm starting from an apartment building, that I must be like 112 feet in the air. Maybe it's like a 10-story building, and throwing the ball up, and it's going to hit the ground. Let me graph this function. The function works the same way in that the coordinates are the same. The x coordinate of any point is the time in seconds, and the y coordinate is the height in feet. So when I graph this function, negative 16t squared plus 48t plus 112, using x's instead of t's, I get this graph, and that shows what happens. Right here at the beginning, the balloon is 112 feet in the air, and the person that throws it up, so maybe it gets up to 120 or 130 feet, and then it goes down, and eventually it hits the ground, and the x-coordinate of that point, the x-coordinate of the x-intercept, is when the ball hits the ground. There's only one question asked in number 4. I'm asked after how many seconds will the ball hit the ground. I'm not asked for the maximum height. I might be able to figure out the maximum height by just playing around. If I did like second calc value, maybe typed in 1 for x, that shows, well, this is hardly believable, but at 1 second, the water balloon is 144 feet in the air, so it's got launched, chucked up pretty decently. It wasn't just dropped. If I did second calc value and typed in 2, it says after 2 seconds, it's 144 feet in the air. It's past its high point. So at some point between 1 and 2 seconds, it got to its high point, which was slightly higher than 144 feet. I would guess if I did second calc value and typed 1.5, at 1.5 seconds, it got to its high point, which is 148 feet in the air. So it actually got chucked up 36 feet, which is probably a pretty decent chuck for a balloon. None of those points have anything to do with the solutions of this problem. So it might help you understand the equation. The answer, the only question that was asked is how long does it take to hit the ground? That's going to be the x-coordinate of that point. And if I count over the little tick marks, I can see 1, 2, 3, 4. In the graph, it doesn't actually cross at an integer. So it's somewhere between 4 and 5 seconds, because the tick mark there at 4 and the tick mark there at 5, the graph touches the x-axis between those two. So I know the answer is going to be between 4 and 5 seconds. So what I'm trying to find in this is when the height is 0 again. I know my answer is going to be some number between 4 and 5, but I don't know it exactly. So I'm going to get it exactly by doing the algebra. The algebra is going to plug 0 in for the height, because that's when it hits the ground. It hits the ground when the height is 0. I'm going to get 2 answers again. One of the answers is going to be a negative number, because if I extended this graph, if I extended my window, the parabola does touch, it does have 2 x-intercepts. This first x-intercept is something that would give an x that's a negative number, and that would stand for a time before I threw the water balloon, and it's not a number that I'm going to consider. I'm looking for this positive x-intercept. The negative x-intercept, although it works for the function, it doesn't work for in reality in terms of this problem. So I need to solve that. And I'd like to just be able to divide by 16 again, but I don't think 112 divides by 16. It doesn't. So I'm going to divide everything by what I think I could do, 8. Does 112 divide by 8? Yes, it does. So I'd like to make my numbers as small as I can. When I have a problem that has an equal sign and an integer common factor, I can divide that common factor out. When I do that, I make the problem a little bit easier to work with. So I'm going to get 0 equal to negative 2t squared plus 6t plus, my calculator told me 14. Really? I guess I could divide 112 by 16. Oh, because I did 112 by 6. Ha ha ha. Divided by 16. I was able to do that. I back up here. I tried on my calculator to divide by 16, and I thought I couldn't divide by 16 because I made a mistake. So I am going to be able to divide by 16. One thing I noticed when I divided by 8, the number in front of the squared was negative. That's not going to help me. When I divide, I'm going to divide by negative 16 as opposed to positive 16. And what that's going to do is it's going to change all the signs. It's going to make the sign in front of the t squared the positive that I like. So recalibrating, actually dividing by 16, 0 divided by anything is 0. On the right side, negative 16 divided by negative 16 is a positive 1, so I'm just going to get a positive t squared. 48 divided by negative 16, if I go 48 divided by 16, it would be 48 divided by 16, it would be 3. But I'm dividing a positive by a negative, so I'm going to write a negative 3t. And then when I do 112 divided by 16, in general, that would be 7. I'm really having calculator issues this morning. But since it's a positive divided by a negative, I'm going to write a negative 7. That's good. I would love to be able to factor this because factoring is easier for me than the quadratic formula. But this is prime. It doesn't factor, so I'm going to have to use the quadratic formula to get my answer. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. It's actually not bad that this is coming up like this, because this is very typical of what you're going to get when you get to calculus, that you'll be solving a problem and it'll need you to pull some algebra skills that you haven't worked with recently up from your long-term memory and just pull them out as needed, and this is good. So to solve this problem, I'm going to make my a equal to 1, my b equal to negative 3, my c equal to negative 7, and I'm going to go t equals negative 3 for the b, plus or minus the square root of negative 3 squared minus 4 times 1 times negative 7 all over 2a, which is 2 times 1. If I do the underside of the radical, the underside of the radical is negative 3 squared minus 4 times 1 times negative 7. So under the radical, I get positive 37. So I'm going to get t equals, this double negative goes positive, so I get 3 plus or minus the square root of 37 over 2. Now I'm going to break this into the two problems. T equals 3 plus the square root of 37 over 2, and t equals 3 minus the square root of 37 over 2. That's going to give me the two x-intercepts. The positive one's the one that I'm looking for. So if I did this, I did 3 plus second square root of 37 divided by 2, taking the entire numerator and putting it in a parentheses. So I have a parentheses around the 3 and two parentheses around the 37, and that gives me 4.54. That's good. So this one gives me, I'm going to round to 2 decimal places, 4.54 seconds. And the other one, if I did 3 minus second square root of 37, double parentheses divided by 2, I get negative 1.54 seconds, which is before the balloon was launched, so that doesn't make sense in terms of this problem. So I'm ready to answer the question. The balloon's going to hit the ground at 4.54 seconds, or this 3 plus the square root of 37 over 2. That's so odd. In general, I like to have radicals in my answers when the algebra yields a radical, but not in a word problem. So I'm going to say it will hit the ground at about, because this is rounded, 4.54 seconds. And I can show you that works on my calculator by going back to the graph, going second calc, going down to the value option, type in 4.54, and when I do that, it shows me, well, I did 4.45. It actually says at 4.45 seconds, it's at 8.76 feet high, which isn't correct. But if I did second calc, value, and type 4.54, I'm probably going to get something with an E. Second calc, value, 4.54. Oh, it says at 4.54 seconds, it's 0.1344 feet. So it's just like a tenth of a foot high. So this is reasonable. It's because my answer is rounded to 2 decimals. If I carried more decimals, this 0.13 feet, which is, you know, I don't know, an inch or two, would be closer to 0. So I didn't expect to get exactly 0 when I plugged in 4.54 because I knew this answer was rounded, but it's close enough. It tells me that I'm definitely in the right area. Had I carried more decimals, then this y, which is the height, would be closer to 0. So that's everything that needed to be handled for that problem. I just wanted to know when the height was 0. I did that by taking the height, h, plugging 0 in for it. I did the algebra to solve it, divided away my common factor, got something that I couldn't factor, so I pulled out the quadratic formula, got 2 answers. I only wanted the positive answer because negative time, the time that I'm solving for, negative time wouldn't make sense in terms of this problem. 6 is actually the same question as 4. It seems like it's somewhat different, but it's essentially the same. It talks about a diver jumping off a cliff into water that's 240 feet below. I give you an equation that models his dive and asks how long does the dive last. The dive lasts until he hits the water. Let me try to graph this function just to show you that we probably can get a reasonable answer by just looking at our calculator. So I'm going to graph negative 16x squared plus 240. And when I hit graph, I'm going to tweak my window back so I don't see this part to the left of the x-axis. I'm going to take my x-min, put it back to 0, because time before 0 seconds, he's not moving. So there's his dive, and he's just going straight down. So he's not going up like the balloon. He's just, he's at 240 feet, and he goes down until he hits the ground. And I might be able to answer the question perfectly without doing any algebra, because it looks like the x-intercept is an integer and the x-coordinate of the x-intercept is when he hits the ground. So if I look at this, I see 1, 2, 3, 4. It looks like his dive is going to last 4 seconds. So he's at 240 feet. He progressively goes down, and then he actually he's going to probably go negative for a little bit. He'll go underwater. So if I extended this graph a little bit, for the first moment or two, it might be reasonably accurate because he might get to be 10 or 15 feet under the water at some point. All right, so let me get this answer of 4 seconds algebraically. I get that by taking the height and plugging 0 in for the height, because that's what I'm wanting to find. His height, his dive stops when his height is 0. I'm going to divide, and again I'm going to divide by negative 16. Dividing by the negative just makes my life a little bit easier when I go to do my algebra. 0 divided by anything is 0. In front of the t squareds, the negatives cancel, I get a positive t squared. And then 240 divided by 16 is 15. Really? And I'm going to get a minus 15. Interesting that my graph, let me try to blow this window up so you can see something that I got fooled by. So let me really crunch down on my windows. I'm going to really ultra focus on this time where I think he hits the ground. So I'm going to make my x's go from 0 to 5 seconds. I don't need to go much beyond 5 seconds because he's hit the ground. And I'm only going to look right by the last few feet of his dive. And so I'm going to make the y max 10 feet. This is going to show me just the portion of the graph, the dive by the ground, And if I look here, there's that 1 second, 2 seconds, 3 seconds, and there's 4 seconds. And here's him diving and hitting the ground. And there's actually a gap between the 4-second mark and when he hits the ground. So he actually hits the ground at before 4 seconds. My guess of 4 seconds was wrong because I thought the graph went right through that tick mark at 4. It didn't. So it's actually slightly less than 4 seconds. This guess was a bad guess because the window that I had didn't allow me to see the x-axis close enough. And I thought he actually hit at 4 seconds, but slightly less than 4 seconds. So I'm going to solve this equation. I'm going to get a number that's close to 4 but less than 4 and pull out another solving strategy. I can't solve this by factoring. I could use the quadratic formula, but that would be kind of odd because there's not a t to the first power term. I'm going to pull out another solving strategy that you need to just have at your disposal, solving with square roots. So I'm going to get the square on one side, the constant on the other by adding 15 to both sides, and I'm going to go square root plus or minus square root. I get plus or minus the square root of 15 on the left side, t on the right side, and I'm going to do a decimal approximation for the square root of 15. So I'm going to go second square root of 15, and I get 3.87. Again, I'm going to round to 2 decimal places just because I, for some reason, like 2 decimals. So I'm going to get plus or minus 3.87 equals to t. I only want times that are greater than 0. I'll take the positive 3.87. So my answer is actually at 3.87 seconds as opposed to the 4 seconds that I guessed wrongly by looking at a graph that just didn't have the detail that I need. So for these word problems, if I didn't make a comment about rounding on the problem, just round to 2 decimal places and I'll be content. All right, new style of problem now. And the next 2 problems are completely different in that they talk about a different situation, but very similar in that they give me an equation and I'm told how the equation, what the equation gives me. The equation in number 8, and I kind of truncated, this p should have been down here, so I rewrote it. It tells me the profit for, the daily profit for a company based on the number of clerks working. Apparently there's an optimal number of clerks. If you have too few clerks, they can't be out maybe on the floor selling. But if you have too many clerks, then some of them are just going to be doing nothing because there's maybe not enough customers for them to be helping. So there's apparently an optimal number of clerks for a chain store to have on the floor so that, you know, that people that need help are getting the help and buying things, and there aren't clerks doing nothing. So the question is, what number of clerks will maximize profit? Well, if I look at the equation, this is another equation that's a parabola, and if I look at the points, the x-coordinate is going to stand for the number of clerks, the y-coordinate is going to stand for the profit that I generate that day for those clerks. I'm going to graph this function and show you how we might be able to get the answer or understand the function easily without, you know, doing algebra at first. If I hit my graph button, I doubt that the window is appropriate. I suspect for the x-min and x-max, since it stands for the number of workers, I don't know how big this company is, but let me just say I won't go over 30 workers. If I don't see a parabola when I graph this, I'll tweak this. But this says I can't have less than 0 workers. My guess is having more than 30 workers is probably going to be too many. So the x's are the number of workers. And then my profits, I know my profit hopefully is not less than 0. I imagine my profit's going to be in the thousands of dollars. I'm going to just make a guess and put 5,000 for my Y max. Maybe they make $5,000 in a day. I'm going to hit graph, If when I hit graph, I see a full parabola and the vertex of the parabola, then my window's okay. If I don't, I'm going to either tweak my X max or my Y max to make it so I can see the whole parabola. Again, this is just guessing. 30 workers, $5,000 in profit is what the X max and the Y max mean. So I'm going to hit my graph button, and I did well with the X's, but my graph goes way too high. So if I change my window slightly, this company's not making $5,000 in a day. Maybe if I change that to $1,000 and hit graph, that's a much better window. So the question is, what number of clerks will maximize profits? Let me see if I can just play. If I did second, calc, value, and typed in 1, it says if I have one clerk working, I'm going to make $275. That clearly I can do better because the graph goes higher. Let me guess, maybe that's like at 10. If I do second, calc, value, and type in 10, it says if I have 10 workers, I make $500. So at one worker, I was beneath the vertex, which is where the optimal, where this graph is optimized. At 10, that was too many. So I need somewhere between 1 and 10 workers. Let me try 7. Maybe 6. Second, calc, value 6. And it says if I have 6 workers, I'm going to make $900. That looks like it's the vertex. My guess is the number of clerks that are going to maximize the profit is 6, and that the maximum profit is 900. The important thing to understand through this discussion is that the vertex is where the answer is going to occur. It's the point where the graph has its maximum. The y-coordinate of the vertex is the maximum profit possible. The x-coordinate of the vertex is the number of workers that will give me the maximum profit. So what I need to find for part A is the x-coordinate of the vertex, because that is where we have the optimal solution. And I'm going to use the negative b over 2a formula to do this. The a is the number in front of the x squared, so in my denominator I'm going to write 2 times negative 25. In the numerator I get a negative from the formula for the b, and the b itself is going to be 300. So I'm going to get negative 300 over 2 times negative 25, which is negative 50. I can do that in my head. The two negatives cancel to be positive. 300 divided by 50 is 6. So the number of clerks that will maximize the profit, 6 clerks, will lead me to maximum profit. To find out the maximum profit, I'm going to go P equals negative 25, and I'm going to replace the x with 6, because that's the number of workers that will lead to my maximum profit. So I'm going to go negative 25, parentheses, 6 squared minus 300 times 6, and I get that I made a mistake. It's plus 300 times 6. I'm going to change that minus to a plus, so I go negative 25 times 6 squared plus 300 times 6, and I get the $900. So the answer to the question in part A, 6 clerks working is the optimal number, and the daily profit that can be made by having these 6 workers is $900. If you have less, then you're missing out on some sales. If you have more, then you're paying workers for maybe not doing work that they need to do. 10 is a similar problem, other than it doesn't deal with profit, it deals with costs and trying to minimize costs. But the idea is going to be the same. I'm going to be given an equation, and I need to understand the equation and then answer the question. It's similar. So this talks about a factory that produces lemon-scented widgets, and the more you produce, the lower the cost to a point, because usually there's discounting for buying in bulk, making in bulk. But at some level of production, the more you produce, the cost doesn't start going down, because you've got to pay more labor, and possibly you're making more than you could sell, so you've got to pay storage fees. So this formula talks about, for this particular company producing these lemon-scented widgets, this is the cost function, My goal is to find the optimal level of inventory, the level of inventory or production that will minimize the cost. So this function, the x coordinate is the number of units that I produce. The y coordinate is the cost for producing that number of units. So we get the x number of units in thousands. So if x comes out to be 3, that means I'm going to produce 3,000 units. If x comes out to be 9, it means I'm going to produce 9,000 units. So the x coordinate of what I'm getting here when I graph this is the number of units that I'm producing. The y is going to be the cost. I have no idea, unfortunately, what numbers make sense here. I'm going to graph this function to try to understand the answer, and then I'm going to do the algebra. And it's not going to be very pleasant algebra because the numbers in the problem are really unpleasant. If I just hit graph, I'd love to see a parabola, but I don't see a darn thing, which is too bad. I have no idea what to set my window at. I'm going to cheat and hit second table and start looking at the numbers in the table. And it tells me that the numbers have to be way up in the thousands. And it also makes me think my x's have to be way bigger. Let me tweak my window quite a bit. I'm going to make my x max get big. Maybe I get to produce 1,000,000 units. Let me make my x max go to maybe 500. And then costs might look like they're in the thousands. Let me make my y max 100,000. And I don't really have any idea if this even makes sense, but I'm going to hit graph and hope that I start to see a parabola. And if I don't, let me try this. Second calc value, type in 500. Wow. I wonder if this function is a bad function. Looks like I need to go way farther out. So I'm playing a little bit because I have no idea what the answer is. I haven't done the problem ahead of time. Haha, finally. I changed my window to go from 0 to 5,000, and I started to finally see a graph. I'm just going to have to work the problem, unfortunately, and I'll do the graph later. I'll work the problem, then show you, having the problem worked out, how I can get the graph. But I'm just not clever enough right now to figure out how to get this darn parabola to show, so I can show you the answer and then back into the answer, which is okay. I don't need to know the answer to be able to do the algebra and get the answer. I don't need to have the answer ahead of time. I don't need to have the graph staring at me. It's nice if I have the graph staring at me beforehand, but I can do it without it. So I know that eventually this is going to be a parabola. It's going to open upwards because the number in front of the x squared is positive. The vertex is going to be a minimum. The x-coordinate of the vertex is going to be the number of units that lead to that minimum. The y-coordinate of the vertex is going to be the minimum cost. So the algebra I need to do is I need to find the vertex. The x-coordinate of the vertex is the production of level that gives the minimum cost. The y-coordinate is the minimum cost. Once I have those two answers, I'll be able to make a picture a lot better. So I'm struggling here to figure out what window to make the answer pop because I don't know the answer ahead of time. And the numbers are such that I just didn't have a feel for what numbers to make that would make sense, which doesn't matter though. So I'm going to use the negative b over 2a formula to find the x-coordinate of the vertex. The b is the number in front of the x term. So I'm going to use a negative from the formula, and the b is going to be negative 8.504. And then for 2a, I'm going to put 2 times 0.04. So the double negative in the numerator is going to give me 8.504. The 2 times 0.04 in the denominator is going to give me 0.08. So now I'm going to do this division. I'm going to go 8.504 divided by 0.08, and I'm going to get 106.3 thousand units, so that's 106,000 units. So the vertex is going to be at x equal to 106. Let me find the y-coordinate of the vertex by plugging in 106.3 for each of the x's. And when I do that, I go 0.04 times 106.3 squared minus 8.504 times 106.3 minus 25,302, and I get that this problem is, this minus should be a plus. That's the only thing I'm convinced. The reason I was struggling with this problem so badly is that I probably blew a sign on this. So let me make that minus a plus, change the problem. It won't impact the x-coordinate of the vertex, but it's going to impact the y-coordinate of the vertex. Let me recalibrate with an improved problem. I believe the reason I was struggling so badly is that the problem itself, because this is the first time I've done this problem, was written, and as I typed up the problem, I blew a sign. So I changed this minus to a plus, and now when I hit enter, I get error syntax because I'm apparently too many. That should be 106. I have an extra decimal here. Now when I hit that, I get a much better number that makes sense. It would say that the cost would be $24,850, and that's the minimum cost. Let me now redo the function, changing that minus to a plus, and make my window show the parabola. So I'm going to need my x's to go to at least to 106. I'm going to make my x's go from 0 to maybe 200 units or 200,000 units. And my y's are like the minimum cost is $25,000. So making my y's go up to 100,000 actually makes sense. This window with the improved sign going from 0 units to 200,000 units, because the units are in thousands, going from a cost of 0 to a cost of 100,000 is going to produce, well, maybe the 100,000 was too big. Window, let me make this go to 40,000, and now hit the graph. I'm really unhappy. What is going on here? Y equals 0.04x squared. Let me just retype it. 0.04x squared minus 8.504x plus 25,302, enter. I'm going to ultra focus on this 106 on my window. I'm going to make my window go from, I don't know, 80 to 120 on the x's, and 0 to, still that 0 to 40,000 feels good, but I'm going to make 0 to 30,000. And now when I hit graph, I'm really unhappy with that picture. Feeling perplexed right now. Let me do second table to peek out some y's here. Oh, the costs don't vary that much at all. I'm gonna have, when I hit second and start looking at the table and looking at the costs, I'm way too aggressive on my y window. So this is the beauty of not having done a problem before, thinking that you understood the problem, the numbers a little bit better than you do. And it looks to me, wow, really? It looks to me like the y's, I probably just need to go to 26,000 or even 25,000. It still might just look like, it does. I got something messed up. Y equals clear, 0.04x up arrow squared minus 8.504x plus 25,302. The problem is that the window needs to be hyper close to this 24,850. Let me tweak my window one last time and make the y's just show, I'm going to show just this. I'm going to go from like 24,500 to 25,000, and I'm not even sure that's good. I'm going to go 24,800 to 24,900. This is a horrible, there, I can finally start to see a parabola. So I was having ultra hard problems because I just didn't have an intuition of what this function should look like, and I didn't realize the viewing window that would be appropriate. Even though I could answer the question without seeing the graph, I was struggling horribly to get a picture that you can see. And so now I can blow this up a little bit. Maybe I can go from 0 to 200 on the x's, and we're even going to refine this better. 24,825 to 24,875 on the y's. And if I do this, I'll probably see a much better picture there. With an incredible amount of labor, I'm able to get that vertex. This is the cost function. On this really refined window, looking between 0 units and 200,000 units, looking at a cost of $24,825 to $24,875, I'm finally able to really see the parabola in the light that I'd like to see it. Now I can show you that if I do second calc value 106.3 and hit enter, that shows me that that is the minimum of this. So doing this problem with my calculator that I wanted to do, it was just horrendously embarrassing that I couldn't get it because I just didn't expect it. The window that I needed really surprised me. But nevertheless, I'm able to answer the question. The number of units that are going to minimize the cost is the x-coordinate of the vertex. So this is 106.3, and it's in 1,000 units. So it's 106,300 units. And the minimum cost is $24,850. I really like to be able to show you how the graph on your calculator relates to this, but the numbers, this 0.04 relative to that 25,000, the discrepancy in how small that number is relative to how large that number is made the window just painful to come up with. So sorry that I struggled so long to get a window that actually you could see the vertex of the parabola, because ultimately that's where the answer is. So it really tested my patience, to say the least, to figure out that how to get a window. But you don't need the window, you don't need a graph to answer the questions. So that's the first style of problems. The first 10 problems all have equations given in the problems, and I need to use the equations to answer the questions. The next problems are back to regression analysis. And problem 12 is something I stole from the internet. It basically says that in Antarctica, they studied the efficiency of photosynthesis for some grass, and for different temperatures in Celsius, they talked about how efficient the grass was being in its photosynthesis. So it looks at, like, at 12 degrees Celsius, which I'm not sure if that's like 60 degrees. I can't do that in my head. It was 95% efficient. At 30 degrees Celsius, which is probably like 80 degrees, it's at 34% efficient. At negative 1.5 degrees Celsius, which is below freezing, it was 33% efficient. So it just shows me for different temperatures in Celsius how efficiently this grass was photosynthesizing and making food, I guess. So it's nice to know what the x and the y's represent. The x is the temperature, the y is the percent of efficiency that this graph is photosynthesizing. The instructions say make a scatter plot of the data, so let me do that. But it says I don't need to make a copy for my paper because that's just insanely tedious. So I'm going to hit my stat button, hit enter, clear out the list 2, clear out the list 1. I'm going to do the x's as the temperatures. I'm going to go negative 1.5, 0, 2.5 degrees Celsius, 5, 7, 10. So this is hopefully a repeat of something you've done recently. So those are my x's. Now I'm going to do my y's, 33, 46, 55, 80, 87, 93, 95, 91, 89, 77, 72, 54, 46, and 34. I don't feel like I did that properly, so I'm going to double check my points. I always double check my points. So I see negative 1.5, 33, 0, 46, 2.5, 55, 5, 80, 7, 87, 10, 93, 12, 95, 15, 91, 17, 89, 20, 77, 22, 72, 25, 54, 27, 46, 30, and 34. So I have all the points in. Now I can make a scatter plot by hitting the zoom button, either arrowing up or down till I find stat. And then when I hit enter, my calculator plots that parabola that I have in there, which I need to get out. So I'm going to hit my y equals, clear out my y equals, and I need to turn the plot on. So I'm going to go to plot 1, hit enter. I'm going to hit second in stat plot, hit enter on plot 1, turn this plot on. If I don't have the plot on, it's not, the stat plot's going to work. Now I'm going to go zoom in stat plot. And now it makes a picture. And that picture, it certainly doesn't look like a straight line. It looks a lot more like a parabola than a straight line. In section 4.2, I think it was, we fit a line to the data and use the line to make predictions. If I fit a straight line to this data, it's not going to be that good to make predictions. So this is the first thing. It said make a scatter plot on your calculator. I'm not copying this to my paper. Now it says use a graphing calculator to fit a linear function and a quadratic function to the data. So I'm going to do stat calc, do what we did before, linear regression. Linear regression gives me the equation y equals negative 0.15x plus 70. So the linear equation is y equals negative 0.15x plus about 70.06. And it says r is negative 0.06. All our r's in the last problem were like over 0.8. Since the r equals negative 0.06, this is not a good predictor. For lines, the r has to be over 0.8 for it to be a good predictor. So a line, if I graph this line, which is y equals negative 0.15x plus 70.06, if I graph that line's going to be useless in making predictions about this data. So I'm going to clear that line out because it's not good. And I'm going to do something called quadratic regression. Quadratic regression is going to find a parabola, an equation of a parabola that fits the data. And because this data looks like a parabola, I think the quadratic regression is going to give me a good predictor. And for whatever reason, our calculator, when it does the quadratic regression, gives me something, an r squared, and not an r. And I couldn't find anywhere online what values of r squared are going to be good. So I'm going to just, because the data looks like a parabola is going to fit, I'm going to assume this is going to be a good predictor. So I hit my stat button, arrow over to calc, go down to number 5 that says quadratic regression, and I'm going to try to pluck an equation out of that. eventually. Notice my calculator took quite a instant to do this. This means by hand this was a nuisance. Linear regression by hand is unpleasant, but not that hard. Quadratic regression by hand is rather unpleasant, to say the least. So if I look at the numbers, it says if I take the value of a and put it in front of the x squared, I don't know if you'll be able to see this, but it's going to say y equals 2. And in front of the a, I'm going to round this to 2 decimal places. So in place of the a, I'm going to go negative 0.25. And then I'll see the x squared next to the a. And then for the b, I'm going to put a plus, and I'm going to put 6.77. And then the x. And then c is going to be plus 46.37. The r squared is a measure of how good it fits. The closer this is to 1, the better the parabola that we're going to have is going to fit the data. If the r squared was 1, it would go through every point perfectly. It looks to me like this equation, when I graph it by hitting my y equals and going negative 0.25 x squared plus 6.77x plus 46.37. When I graph this, it does a heck of a lot better than the line in terms of it matches the data really nicely. So which equation has the best fit? I would say the quadratic equation has the best fit, because when I graphed the line didn't go close to many of the points, but when I graphed the quadratic, or the parabola, which is a quadratic equation, it looks to fit the data really nicely. So I'd say the quadratic equation has the best fit. So I've done part A. I made a scatter plot. I used my graphing calculator. I found a linear and a quadratic equation. I plotted both. The linear equation didn't look to fit the data at all. It's not going to be useful to make predictions. The quadratic, or the square, the parabola, looked to fit the data real nicely. So I'm going to use it when I answer questions and make predictions about the problem itself. So the quadratic equation seems to have the best fit. Graph the function of best fit on your calculator. I said, don't make a copy. It just seemed ridiculous to keep you making copies of these. So this is going to be on my calculator. I'm not going to force you on the test to copy these graphs. That's just tedious. Now it says use the equation to determine the optimal temperature at what photosynthesis is most efficient. I know that each point, the y coordinate is the temperature, and the x coordinate is the temperature. The y coordinate is the percent efficiency. I don't know if that's spelled right. The y coordinate of the vertex isn't what I'm looking for. It's the x coordinate of the vertex. So I'm going to get the vertex, and the equation that I have is y equals negative 0.25x squared plus 6.77x plus 46.37. The optimal temperature occurs at the x coordinate of the vertex. I'm going to find the x coordinate of the vertex by using the negative b over 2a formula. So I'm going to do the x coordinate of the vertex using the negative b over 2a formula. The b is the number in front of the x term, so I'm going to go negative 6.77. And then the a is the number in front of the x term. It's going to be 2 times negative 0.25. This is going to be negative 6.77. And then, even though I could do this in my head, I won't. 2 times 0.25. That's going to be over negative 0.5. So I get negative 6.77 divided by negative 0.5. And that gives me 13.54. So this says at 13.54 degrees Celsius, photosynthesis is the most efficient. So if I want to answer the question, the temperature is going to be 13.54 degrees Celsius. Could show that on my graph. If I did second calc value, typed in 13.54, that's going to be smack dab at the vertex. And again, this is just a prediction. If you look at my table, there probably are temperatures that are slightly more efficient. But when I'm using an equation to make predictions about data, my prediction isn't going to be the ultimate perfect, but it's going to be pretty close to the best situation, the most accurate that I could get anyways. So the answer to this I had to understand the only algebra that was required is in part E. Everything else was calculator. And the optimal temperature, because the vertex has a temperature and the efficiency, the vertex contains the optimal because I want the optimal temperature. The x coordinate of the vertex is what I was searching for. Okay, I don't know how many more of these problems we have. Just one more. So problem 14 gives me a table that you may not be able to see, but it's the birth rate for per 1,000 women of whose age is X. So at an age of 12, it says for every 1,000 women, there's one kid born. For 17-year-olds, there's 42 children born for every 1,000 women. For 22-year-olds, 106, or just about 10% of 22-year-olds. 106 out of every 1,000 22-year-old women have babies. For 27-year-olds, when you're 27, 117 out of every 1,000 have babies. So this was in 2007, this data was taken. This is real data that real data, assuming the website I got it from had real data. But it makes sense that 1 out of every 1,000 12-year-olds has a baby, and almost 100 out of every 1,000 32-year-olds have a baby. So I have to understand the x coordinate is the age, and the y coordinate is how many women out of every 1,000 have a baby. Now I'm going to make a scatter plot of the data, going stat, edit, clearing out the list that I have, typing in the 12, the 17, the 22, the 27, the 32, the 37, and the 42. Clear, crazy. And then going over to list 2, typing the 1, the 42, the 106, the 117, the 100, the 48, and the 10. So I've put the data in. I'm going to make sure I haven't messed up. 12-year-olds, 1 baby per 1,000, 17, 22. And at 42-year-olds, only 10 of every 1,000 42-year-old women have babies. Now I'm going to do second stat plot, but to do that, I'm going to go zoom and arrow till I find zoom stat. It's going to plot the data. Still have that old line on there I need to get rid of, so I'm going to hit y equals, clear out that equation that was in there, get back to my graph. Again, that looks a lot more like a parabola than it does a line. So if I do linear regression, if I do stat, calc, linear regression, I expect the R to be really small. The linear regression in part B, the linear regression is the equation y equals to, I'm going to say 0.24x plus 54.02. How small the R is at 0.05, which means if I graph that equation, 0.24x plus 54.02, it's not going to fit the data that well at all. So using that line to make predictions is going to be horrible. So I'm going to clear that out because that line is no good. Now I'm going to do stat, calc, quadratic regression and get the equation y equals to, I'm going to go negative 0.49x squared, so negative 0.49x squared plus 26.75x minus 254.6. The R squared is the measure of how good the fit is. Over 90%, 0.9 is very good. So if I hit y equals and graph this, negative 0.49x squared plus 26.75 minus 254.6. If I hit my graph, that equation, that tells me I messed up because I don't see the equation. Let me do that again. Y equals negative 0.49. I forgot the x next to the 26.75. So 26.75 x minus 254.6. Now, when I hit graph the line, the parabola goes through the data almost perfectly. So I could use that equation to make predictions way better than I could the linear regression. There are many types of regression. Linear and quadratic are just two of the dozens of type of regression. And it depends on how the data graphs out, what style of regression that you're going to use. When you take a stats class, you'll learn way more about regression than you are here. So the quadratic regression is definitely a way better fit. So I made a scatter plot on my calculator, didn't need to show it here. I found the equation for the linears and the quadratic regression. The quadratic regression fit way better. I graphed them, and the part E is the only question, and part E says predict the birth rate of a 35-year-old woman. It doesn't say anything about optimal, what age do women have the most babies. So it doesn't ask me to do any optimal thing, so it's not asking me to find a vertex. This is just asking me to plug 35 into the function. I'm going to go y equals negative 0.49 times 35 squared plus 26.75 times 35 minus 254.6. When I do second calc value, that's what my calculator's doing. It's plugging a value in for x. So I'm going to do that. Do second calc value, type the number 35 in, and it says I get 81.4. So this gives me 81.4, and I probably need to round that. So it says for every 1,035-year-old women, they have about 81 babies. So I'm going to say the birth rate is 81 per 1,000, and that's all there is to do for 14. So we get a new style of regression and a bunch of word problems. So if I wanted to break the word problems into sections up through problem 10, what the problems had in common is they gave me a formula, and I needed to use that formula to answer the questions. The next two problems, I need to use regression to come up with the equation. And then once I had the equation, I could figure out the answer, and the only question that required algebra is the last question. Hopefully, I did well enough there that you got through these and you kind of understand them okay.